Hi everyone, now I'll be presenting problem 7 from this year's TST. Problem 7 is as follows. 5 people, numbered 1 through 5, participate in a round-robin tournament. Person I wins against person J with probability I over I plus J, and the outcome of each game is independent. What is the probability they all win the same number of games? Okay, let's see. So, first, note that, because it's a round-robin tournament, every pair of players plays exactly one game. So the total number of games is, let me change the pen, 5 choose 2, which is equal to 10. So the total number of wins for each person, because the wins are split equally, because everyone has the same number of wins, is 10 divided by 5, which is 2. So 2 wins per player. Now, suppose we have a setup of the tournament that works. In other words, we have chosen a winner for each game already, so that every player has won 2 games. What is the likelihood of this happening? So we know that the likelihood of each game getting won, I against j, is I over I plus j. Instead of multiplying these fractions together, we will consider the numerators and denominators separately, because something interesting happens. So for the numerator, it's the product of I for all I, where it's like I to the n, where n is the number of games they win, right? But we know that every player wins 2 games, so n is equal to 2. In particular, that means we just have 1 squared times 2 squared times 3 squared times 4 squared times 5 squared. This is our numerator. Now let's look at the denominator. There's 1 I plus j for every game played between I and j. So the denominator is actually 1 plus 2 times 1 plus 3, 1 plus 4, 1 plus 5, so on and so forth. 2 plus 3, 2 plus 4. You get the idea. This denominator is 3 times 4 times 5 squared, 6 squared, 7 squared, times 8 times 9. This is just combining all the terms that are equal. So see that we have one number for each of the possible values of I plus j. 5 is squared because 5 can be written as 1 plus 4 or 2 times 3. So now computing this value, we get 1 squared, 2 squared, 3 squared, 4 squared, 5 squared over 3, 4, 5 squared, 6 squared, 7 squared, 8, 9. This is the value we want to compute. So first, we can cancel out 5 squareds in the numerator and denominator. We can cancel out this 3 and 4 with these exponents here. Now on the top, we have 2 squared times 3 times 4, which is equal to 48 over 6 squared times 7 squared times 8 times 9. Now 48 we know is 8 times 6. So we can cancel out this 8, this exponent here. 48 goes away, and we get 1 over 6 times 7 squared times 9. That's the probability. This holds no matter how our setup works, who we choose to win each game, as long as everyone each wins 2 games. So now we just need to count the number of setups where each person wins 2 games. These are our 5 players, numbered 1 through 5. So the first player, we have 4 choose 2 choices as to who that person beats. Suppose player 1 beats players 2 and 3. Now, between players 2 and 3, there is exactly one winner in their game. So, suppose we just choose player 2 to win. Then that's times 2, because these two cases were either 2 wins or 3 wins or symmetric. So we know they're the same number. So we just multiply by the 2. Now, player 3 has already lost 2 games. So player 3 must win his remaining 2 games. Now we have one more degree of freedom, which is who does player 2 beat? Player 2 has already lost 1, and he has won 1. And player 2 must play against player 4 and player 5. Suppose player 2 beats player 4 instead of beating player 5. Once again, these two situations are symmetric, so we can just count them as equal and multiply by 2. So now I claim that from here the tournament is fixed. Note that player 2 has already won 2, so player 2 must lose the remaining game. Player 1 has already won 2, so he must lose the remaining 2. And now all the games are determined except for the game between 4 and 5. Player 5 has already won 2 games, so player 5 must lose the last game. So the tournament is in fact determined. So the total number of tournament setups is 4 choose 2 times 2 times 2, which is equal to 24. So our final answer is 24 divided by 6 times 7 squared times 9. So we can simplify the 6 out of 24. We know 24 divided by 6 is 4. So we cross out the 6. This becomes 4. And now our final answer is 4 out of 7 squared times 9, which is 400 and I believe it is 41. And we're done.